All right, so basically the idea of 12.2 is going over what does it look like to pass on sex, so like male and female, and then what are some of the sex-linked disorders. And we've already talked about this some, where like you have, when you're looking at a karyotype, you have the larger X chromosome, so it looks like this, and the smaller Y, where if you have 2 copies of the X chromosome, that would go with female. And then if you have a 1X and 1Y, that would go with male, right? So, yeah, there you go. Now, if you're a male, let's say, because like a male's gonna have 1X and 1Y, if you were to look at the chromosome structures, there actually is like a portion of like the top, like this portion here and that portion there of the Y chromosome is homologous, meaning it does have some of the same genes at the top and bottom that a female, that is not female, but on the X chromosome, those would line up because these chromosomes are homologous. They would want to be able to, for the male, the top portions and bottom portions would want to be able to match up so they can be linked together whenever you're doing meiosis, if that makes sense. Like during meiosis, and you're doing crossing over, you'd want to make sure these can line up properly. That's what they mean by the Y chromosome having homologous portions of it. That's not super important to understand, but that is what they're trying to say there. Yeah, so yeah, for behaving during meiosis. All right, so if you were to look at like a cross here, males, we talked about this earlier, where like males determine maleness, so like the father is going to determine whether or not they can have a son. So like that's because the father has the Y chromosome, so he can make a sperm with the X chromosome or the Y chromosome. 22 plus is referring to the autosomes, chromosomes 1 through 22. And that's because females have 2 X chromosomes, so females can only make eggs with X chromosomes. Okay. All right. If you're referring to a gene that is only on the sex chromosomes, we call it a sex-linked gene. It's a gene that is linked to the sex chromosomes, either the X or the Y chromosome. Okay. And if you have a disorder, some sort of issue with one of those genes, we call it a sex-linked disorder. If it's specifically a gene on the X chromosome, it's an X-linked gene. If it's on the Y, we call it a Y-linked gene. And they say there are a few of these. Why would there only be a few of them? Why would there be fewer Y-linked genes than X-linked genes? Thomas? Yes, the Y chromosome is smaller, so there's fewer genes. That's also a big reason why there's fewer Y-linked genetic disorders, which I'll show you a little bit later on. So then the purpose is like, all right, well then, what are the genes in the Y chromosome do? Most of them have to do with like genes that would determine like maleness, right? The male kind of sex characteristics. Now the X chromosome, because males and females have an X chromosome, the X chromosome will actually have genes that can code for other characteristics. That isn't just about like, developing like sex characteristics. Interestingly enough, default is female for like a developing embryo. Like if you were to like inactivate all of the genes on the Y chromosome, the embryo would develop into a male. So that can happen sometimes. Like you could have like someone who looks like physically like a female, but technically they would have a Y chromosome where something happened during the development of the embryo where those Y-linked genes weren't functioning. They weren't being turned on properly. So anyways, that is kind of interesting characteristic there. Yeah, as we talked about earlier, you need 2 copies to be a female. Males only need 1 copy. Males only get 1 copy of the X chromosome. This is kind of a word sometimes people might throw out. It's kind of a snobby word, hemizygous. Why it's not homozygous is because you can't have 2 X chromosomes as a male. They need to be a female. So hemizygous is just saying like you Like you only have one copy of the allele, essentially. This is also why X-linked disorders are much more common in males. Because males only get one copy of the X chromosome, if you have an issue with your X chromosome, that's a big issue. Females get two copies of the X chromosome, so if they have a defective gene on one of their X chromosomes, they have like a backup one. They have like a spare tire, essentially. So if you're looking at, say, a trait like color blindness would be here, females can be carriers of color blindness because they can have that extra X chromosome. Males either have color blindness or they don't have color blindness because they only have one X chromosome. So what you're seeing here is if you have a male with color blindness mating with a female, it's homozygous dominant for just normal vision. They can only have offspring that are female carriers. And really appreciate that. Because the male, to have a male offspring, they have to give the Y chromosome. This father can't pass on his defective X chromosome. That's why fathers can't pass on X-linked disorders. Okay? Only females can pass on X-linked disorders because here they're a carrier of that X-linked disorder. Okay. So here, then now we're looking at, all right, what would happen if like this female here mates with a normal male? Then this is when you can get the appearance of the color blindness. So again, females are the only ones you can pass on the X-linked disorders because males have to. Well, let me back up. Males can pass on X-linked disorders to female offspring, but they can't to their male offspring because they can only give the Y chromosome to their males. They can't give their X chromosome. All right. So if you're looking here, so then in this case, a female can then make a male who has the color blindness trait. Okay. And then if we're looking here, this should just be another example. So a female mated with a male who has color blindness, half of the offspring would have the color blindness. Okay. Some other X-linked disorders: color blindness, Duchenne muscular dystrophy, hemophilia. People have like issues with blood clotting. Those are all like linked. An issue with a chromosome on the X, an issue with a gene on the X chromosome. Again, for AP Bio, the exam, they don't make you memorize what exactly each of these conditions are, or even that these are X-linked. You don't actually have to memorize that. When I was in school, you did have to memorize it, but fortunately you don't for your purposes. Now this is interesting. So because females have two X chromosomes, that raises the question, do females make double the amount of like a gene on the X chromosome? And the answer is no. Females will actually randomly inactivate one of their X chromosomes. The chromosome that gets inactivated, we call that a bar body. And what's interesting is not every cell in a female's body has inactivated the same X chromosome. So what happens is a female could be a mosaic for that character. So a calico cat is a classic example here. So if you look at a female calico cat, some of her, like if you focus on the cells at that portion of the calico cat's body, they would have inactivated the gene that carried the orange fur allele. That X chromosome got inactivated. So they're only going to activate the gene that makes the black fur. But then this portion of the cat's body, they inactivated the X chromosome that had the black color allele, and they're only expressing the orange color allele. So there you go. Any questions about that? Some of the stuff with the mastering bio. Let me